those photos will help you with some of it.
That's crazy.
Oh my God. That's crazy.
That's
If
crazy.
you wait,
Bro, where's what's her name, bro? She like disappeared like my
She's
dad.
not here.
No,
She
not
left.
like she don't. Who?
I don't know about your mom.
Bro, she got kidnapped again.
That's crazy.
That's
For
crazy.
real. Just like my life, bro.
That is crazy. That's crazy.
yeah, y'all stop.
That's rude.
You said it like twice.
Okay, guys, this is what you need to do right
Why are you
now.
back there?
So I don't get distracted.
Okay,
I'm at that point.
alright,
Come on,
alright.
bruh.
Guys, I've written it up here, page 132, numbers 41 through 47 is a review of what we've done. We're going to do the math problems together. But y'all can knock out these multiple choice. Y'all, I'm speaking.
Okay.
Y'all can knock these multiple choice out really fast. I'll check it, we'll go over it, and then we're gonna do, the problems together. Okay? Alright, so you need a blank sheet of paper.
Can I get a piece of paper, please?
It's not the best thing to do because it doesn't have lines on
I get a
it.
piece of paper.
Wrong.
That's crazy.
Oh my God. That's what I'm saying.
Nate, do you have paper?
Do not.
Okay.
Nah, I get some.
Okay. Please keep the chair on the floor for me.
Yeah, Nate.
Huh? I'm gonna give
Mother.
you this. Who else? I got it. If he wants that, he's got that. Who else? Emery?
Do you want?
Yeah.
Do you have paper?
I need some.
Okay, and what about you, Mark? Alright. So, 41 to 47, this shouldn't take you very long at all. Just put the number, be sure number 41 to 47 and not start with 1. It makes it hard for me to grade.
Do what now?
Huh?
Start
Shut
numbering with the number 41, don't start with 4 or 1, okay?
up. Okay.
Will do.
Cucumber, bro, what? I'm so.
Do I have all the phones? Jemima, where's your phone?
Miss Fuller,
He left his pencil up there.
Again.
my mechanical pencil. It's not gonna take
Yeah, it's
long.
worth a lot.
I'll grab my pencil right quick.
Okay,
Yeah.
It's in the Stanford's room.
okay.
Yeah.
Alright, so, and I'm missing my own calculator, which isn't a good thing, because we're about to calculate. So,
Use your phone.
well, that's what I'm thinking I'm gonna have to do. I would rather not. Mhm. Yep.
Remember when we were talking about how when somebody hits a baseball and how the one, I think, how high the GPE was, and then how low the kinetic energy was? Do you know what page that would be on?
Well, let's see. I can get you to a page about that, but that's not, oh yeah, gravitational potential energy and kinetic energy. That page is on, that page number is 122. Okay, let me see, I'll read that, see what we know. Okay, Jake, we're gonna talk about, the answers. If any of those you missed, we're gonna talk about it here in a second. And let's get a name. 10th, the date is the 10th. Charles, I need a name on things. Date.
Bro, I literally wrote my name at the bottom.
Well, I didn't know to look at the bottom, okay? Alright, Jemiah, yes, do this. Mark, are you finished?
Almost.
Okay.
Almost isn't good enough.
Y'all, if any of you have it, well, I don't think y'all done a poster, but somehow or another, I've gotta get all these posters somewhere they need to be. We're getting ready to calculate here in a minute. Yes, sir. Sign out for me.
I got it back.
Good job.
So Miss Fuller, I had to go all the way upstairs so I could look in the room, and then I had to go with Miss Stanford to the Keystone room
Skill issue.
because Laney took it.
Womp womp.
That's why it took so long.
Okay, here's another case, Nate, where I was saying, please number 41 through 47.
Don't bug us.
You hear me, Nate?
You wanted,
I mean, I know I can look at it and tell what you did, but by doing it this way, if we had any more to do, I wouldn't be able to grade it, cause you changed the numbering, but I think I'm with you right now, I can tell if this is right, cause your answers are right.
Womp womp.
Okay, so now I'm looking for Mark and Emery and Jemiah.
where we going to 47?
Dog.
Yeah.
He's on the board now, Emery.
Oh, I didn't even
He's
look.
blind. Gotta give him a break. He has Alzheimer's disease. Let's go. I got a zebra.
Okay, we're gonna go back over it. Oh, this is.
I'm
your
so smart,
bit.
bro.
Let me
I'm
do
so
first.
smart. I got a zebra. I'm pretty sure.
Alright, that's pretty good, Jemiah.
You're not a
Go
grandpa,
over the
walk
answers.
faster.
Chuck, you already turned yours in. Okay, so now, lonely back there, Emery, we're waiting on you.
Can I, see if I can get the ones I got wrong and go back over them?
We're just gonna go over them together, cause it's just a few of these.
I got everything wrong.
And, we're gonna do this together. But I do want you to pay attention to the formulas up here. If you're finished, take a look up here, so we don't have to constantly ask. Work is equal to force times distance, right? Because no work is done if distance is zero. It has to move. And then efficiency is work, I meant to put output divided by input. Yeah, work output divided by work input times 100. Now why? Well, first of all, efficiency is in percentage. But not only that, work output is always less than what you put in it because there's no perfect machine.
Bro, I hear Christmas music.
Okay? And so efficiency's in percent, but mechanical advantage is just the ratio of output to input, and if it's a good machine, it's giving you quite a bit. Y'all stop. Mark, if you can't stop laughing at Charles, I need you to go to another
I think you just
seat.
need to turn around.
I ain't doing nothing, bro. I go to the bathroom when they get back.
Yes.
Yeah.
Let me grade this one and then we'll move on.
Or you could just stop looking at me, Emery.
You looking at me.
Oh,
Wait,
you
what's
looking at
this
me,
thing?
bro?
You like me or
Hey
something?
guys, stop.
Bro, you were literally holding Nate's hand yesterday.
Hey, that's not
Both of you.
appropriate for physical science class. Keep all those conversations outside.
Bro, it's literally physical.
It's full of
Okay, just stop.
Oh, it's physical.
I'll go over it in just a minute.
Think about it.
Okay, then that's pretty good. Emery, let's go on over this together.
Good job.
Okay, the first, number 41 says, using scientific definition, which statement is always true of work? And the answer is C. It's always a transfer of energy. Okay? Whether it's mental energy that you're putting on paper or whether you're pushing a box. It's a transfer. And then number 42, the gravitational potential energy of a cucumber Earth system. Now that's all that means is that it's actually gravitational potential energy. And you're just, when they call it a cucumber Earth system, it's just, a system is something that you're looking at. You just draw a box around it. But the answer is mass, because if you think about the formula for gravitational potential energy, it's mass times gravity times height. So it's going to be mass that's going to make the difference, because gravity's going to be the same for Earth. Okay, and I don't know that they didn't mention anything by distance, but it is mass, so that we wouldn't have, they didn't mention height, that just left us with mass as an option. And on 43, which cannot be done by a machine,
Increase work.
yeah, that's a terrible machine. If you have to increase your amount of work and you have no mechanical advantage, that's a terrible machine. So the answer is B, increased work. Alright, number 44 says, which factor increases as the efficiency of a machine increases? Now let's look at this. Efficiency is in the numerator, so everything else in the numerator will increase as well. Now this on the denominator will go down if efficiency goes up. So the answer should be work output on that one. Let me see, work output is B, and the answer is B. Okay. On 45, which energy transformation is happening in the figure above?
And GPE to kinetic energy.
That's right. Gravitational potential energy is, there is a height difference there. So the height makes a big difference, in that. So GPE to kinetic energy. Okay, and you get a little bit of a pause at the top.
I should have put B for everything, bro.
There were several B's, but anyway,
There's
you
like
get
4 in
this
a row.
little pause at the top before you change directions. So the gravitational potential energy turns into kinetic energy. The highest kinetic energy is where, at what point?
The very top.
Infinity.
No, the bottom.
The very bottom, when she's right there at the bottom, that's the highest kinetic energy, and something
And
like
then
this.
the lowest is when she's at the top.
Right before she gets to the top. It's almost, it hasn't quite changed into gravitational potential energy yet. Alright,
number 3?
B.
increased work, if you're talking about 43, okay?
So it's B.
Machines don't increase work, is what I was telling them, that's not a good machine. Machines are supposed to,
What's 46?
multiply the force that you're putting in it. Alright, and then number 46, friction causes mechanical energy to be converted into what?
Nuclear. Thermal.
Kinetic,
Mm-mm. What gets hot?
Thermal.
thermal,
And friction, if you got friction in something, you might even get sparks.
It's thermal.
Alright, and the 47 says, what term indicates the number of times the machine multiplies the input force?
Efficiency.
The number of times it multiplies the input force.
C.
Mechanical advantage, that's how good your machine was. Now, these are kind of a struggle, yeah, these are always kind of a struggle for us, to get through. So the first one, as you know, is always the one that's straightforward. The first one is simply a question about work. And they give you, the knowns are force and distance. So you need to be calculating it out. It says, find the work needed to lift a 20 Newton box 2 meters. Remember, newtons is force. You can actually do that one in your head. What's the force?
well,
Y'all read. Oh, you probably don't know where I am. 133, number 52.
133.
oh, where it says apply math,
10.
Calculate work.
Okay, the force for the book is 20, and the distance is 2 meters. So the answer is 40 joules.
yes,
40 joules.
40 joules.
Now this one gets kind of tough because you're looking at efficiency and they're giving it to you. So efficiency is not the unknown here. So, and this is another thing you have trouble with, is recognizing the known and the unknown, and then having to rearrange a formula. So I'm just going to go ahead and give you the formula that you would use. If you used it straightforward, it would be 20% is your efficiency, right? Are you with me?
Yes,
Okay, and then the, let's see, input work and output. The output is 140 joules. Now, this is your unknown right here. And this is going to be times 100, but we can wait. We can wait on that. So let's just work it out this way. Let's take the 100 out. You know how you can do that? If you take the 100 out and change this to 0.2, that changes that number. Now you've got 0.2 equals 140 joules over input, and I'm going to tell you how to rearrange it anyway. So it would be input times 0.2 equals 140 joules. Okay? Now, you need to get rid of this. So you divide both sides by 0.2. So what is input when you divide 140 by 0.2?
Let me pull out the calculator. Hold on, I got you. 140 divided by
0.2.
0.2, 700.
And that's right. So it's 700 joules. Now here's the deal with this, is I'm repeating myself, but I can't emphasize it enough to you, is that you've got to know the knowns and the unknowns. If it tells you the efficiency is 20%, that's going to tell you that you can't just use the same old efficiency equation for this. I will try to always provide the rearranged equation, okay? So we started out with 20% equals 140 joules, which was output over input, our unknown, times 100. But to solve the problem with having 100 out there, divide both sides by 100. You're dividing 100 by 100, that cancels it. You divide 20% by 100, you get 0.2. That's kind of a challenge, right? But when you rearrange this equation appropriately so that you have input equals 140 divided by 0.2, then you get your answer, which is 700 joules. So notice that this is not a very efficient machine, because if your input is 700, you're losing how much? How much did you lose? Was lost to just waste heat. The difference between 700 and 140.
You lost
560. 560. That's not much. That's not very efficient at all. Okay, there's a lot of heat somewhere in the system. All right, is everybody with me?
Yes, ma'am.
You with me, Jemiah? You sure?
Mm-hmm.
Jake, you with me? Yes, no? Kinda?
I'm with you.
Mark. And Nate, you're usually right there with me, right? Okay, well, let's go on to the next one. Okay, now, 54, read with me. A certain level has a mechanical advantage of 5.5, so where are we going for our formula?
20.0 divided
No,
by.
where are we going for our formula? Mechanical advantage.
The output over input.
Right, so they've already given us the mechanical advantage. So one of these are gonna be the unknown. Output or input, the unknown.
The input. Oh, wait.
The input force is 200 newtons. Okay? The output is the unknown. So, what should you be thinking? What should you be thinking when you see something like this? You've got to solve. You've got to
The
solve for
output.
this. You've got to rearrange this formula, right? So, what it's going to be is we're going to
500.
rearrange it, and it's going to be 200 newtons times 5.5. Remember, mechanical advantage does not have units, and that is going to equal the output. Calculate that out, and what do you get?
470.
200 times 5.5, y'all. I'm
11,000.
sorry.
What?
Take away a zero. I take away a zero. I misread it.
1100.
You took away a zero,
110.
so it's 110 joules. Okay,
That's a lot.
102. Output and input both have joules. Work has joules. Force has newtons. Mechanical advantage does not have any unit.
Wait, isn't that supposed to be 1,100?
No, I took away a zero, I misread it. It was 20 newtons. I misread it. Okay. Okay, I want to ask you if you see this, everybody see this, Jemiah and everybody's looking at this.
Yes, ma'am.
Everybody understand?
Yes,
Yes,
ma'am.
ma'am.
All right, well, the next one is I need to talk you through some of the energy equations, okay? The energy equations.
Okay.
The next one is a question about power.
So, Miss Fuller, what was the reason why you took that 1 0 off of
I
that?
misread it from the, I
Bro,
saw 200 and it was 20, okay?
bro was like deaf.
All right, power is the amount of work over time. Okay?
Yes, ma'am.
Work over time. What is work?
Energy.
Force times distance.
It's stuff we do for money.
It's
So,
3/5.
just a second. So because force times distance equals work, instead of putting work up here, we can put force times distance over time, depending on what they give us in the problem. That's how you know what you should do. Because it's a dead end if you don't. So it says a person weighing 500 newtons. Okay. That, believe it or not, is a force. And as I say, if you don't think it's a force, sit in a chair that won't hold you. You will fall to the ground. That is a force. Weight is a force, okay?
Skill issue.
Is
So-
this number 55?
Yacht.
I think so.
Alright, so 500 newtons. Now, what is the distance they're giving you in 55, number 55? Well, they're giving you, 3 is your distance, 3 meters. And the time is 5 seconds. So 500 times 3 is what?
800. No.
1,500.
Yeah.
5 times 3.
1,500.
469.
15,000.
It's 1,500, right?
Oh, I thought it was, wait, hold on.
Maya, you're stupid.
You're retarded.
At least I know what 5 times 3 is.
Shut up, you feel.
I thought it was 469.
Dog, you said it was 8.
Shut up.
You can't even multiply 5 and get 8.
What's the answer, Mark?
1,500.
Alright, 1,500 divided by 5 is what?
30.
500.
30.
50.
Put it in your calculator and give me a serious answer.
What? Alright, put what in the calculator?
1,500.
300. 300.
Good.
Is that what y'all got?
I don't know.
Yeah, I multiplied. I mean, I divided.
My
Dog.
calculator gave me 0.3300.
300.
Alright, but the thing is, what's the unit for power?
Work overtime.
What's the unit for power?
Jack, Jules.
Not joules.
In
What's on the end of a light bulb when you look at it?
Watts.
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 Dog.
Why?
Alright, so the power there is watt, and the trick to that was knowing that you could use force times distance for work. And if you know these formulas really well coming into the test, and you probably should have note cards with the formulas on it. We can do that here in a minute. You need note cards with the formulas on them, because if you know this, then the minute you see the given, that given's not going to be usable until you choose the right formula. Alright, that's how you know what formula to choose, is by the given.
Do you have no cards?
I have some up here, but we're not where we need to be right now.
So the unit for watt is just capital W.
Now, do y'all remember the formula for kinetic energy? Hopefully we can just use the straightforward formula. Straightforward formula is kinetic energy equals 1/2 times mass times velocity squared. But here's what you gotta remember. Order of operations, you need to square velocity first, multiply it by mass. This is the same thing as dividing by 2. But let's see if just the straightforward equation's gonna fit. Calculate kinetic energy. I'm on number 56. It would be helpful if you just read along. What is the kinetic energy from the motion of a 0.06 kilogram tennis ball traveling at a speed of 50 meters per second? Where is the mass in there?
Kilograms.
You got it.
0.06.
Yeah, 0.06. But you've got to square the velocity, which is 50 meters per second. So what is 50 squared?
500. I
Wait,
mean,
hold on,
100.
wait,
I mean,
no.
That's
No,
about
that's-
10,
That's 500.
that's
25,000.
1,000.
25,000.
2,000.
500.
25,000.
2,500.
2,500.
25,000.
2,500.
Okay, y'all are being just really silly. All you have to do is put it in the calculator and stop saying stuff.
50 times
It's
50.
2,500.
Put it in the calculator, everybody. You're being silly.
2,500.
2,500.
Alright, now, that's multiplied by what? What's the mass in kilograms?
0.06.
0.06, and then that will be divided by 2 because that's the same thing as multiplying by a half. What do you get?
Hold on.
Wait, did we square this one now?
We've already done it. 50 squared was this part of the equation. That
75.
gave us 2,500.
Let's see, hold on.
75.
Multiply this by 0.06 and divide the whole thing by 2.
75.
75.
Alright, 75. 75. Alright, now, I don't know about doing 57 because they're wanting an estimate. And I'm thinking it's gravitational potential energy, but they're using a canyon floor. So we're supposed to estimate that, and that is complex, so we'll skip 57. Speed. We're gonna have to flip around a velocity equation, and that's too complex for
May I
us
sharpen my
as
pencil
well.
in this folder?
Yes. Alright. So, here's some note cards. I want you guys, you're gonna need about 5, you're gonna need the, kinetic energy, gravitational potential energy, mechanical energy, efficiency, and work. Everybody needs one. You've got 1, 2, 3, 4, 5.
Everybody just needs one. No?
5. Everybody
Five.
needs 5 cards. 5 cards. And I'll go ahead and put gravitational potential energy up here.
You got any flashy cards?
Fine.
No, they don't have to be flashing. Girl.
No. This, I mean, call them.
Oh, nothing wrong with you. You got a problem. Like, it's this.
Guys, if it's not necessary to say, don't say it.
No, because you can make it look.
Okay.
Why do you think I'm at the school?
It doesn't,
So
it doesn't matter. Everybody try to limit it.
Exactly. Everybody's trying to learn. You making noise.
Okay,
Don't
Jemiah.
even, you are not.
Jemiah, don't get no back and forth.
Yes, ma'am. You know, right. You're right.
Alright, let's look at it again. Let's look at it, make sure you know to recognize this.
Oh, I didn't give myself none.
Oh, you better get yourself some.
You right.
Okay, Mark, we had a discussion
Turn into a
yesterday. No extra comments
Ribbit.
at all. No extra comments, because you want to stay out of trouble, and we talk about this all the
frog. I
time.
call cat.
Alright, let me write my E a little bit better.
I'm trying to keep him out of trouble for you.
Alright, so you've only got 5 of these to write down, but if I were you, I would do 1 on each card in case we have to rearrange the equation. and then you can put that on the other
Running
side.
that down.
Yeah, each card. The first one is work equals force times distance. Efficiency is work output divided by work input times 100. And your unit is just a percent sign.
So
Okay.
just write the formulas down on these note cards.
Give one formula a card because that'll give us time or a place to write the rearranged same formula. Okay?
Oh,
So efficiency is work output divided by work input times 100. Mechanical advantage is simply output divided by input.
Wait. Right there where it says efficiency, is that first one work? Is it just work?
No, it's work output. It looks like work.
Charlie Conway.
Big head.
Work output divided by work input times 100. Jacob, you got all these written down? One on each card. Then mechanical advantage.
Hey, what do I do with the last five?
Huh? Did you get too many cards?
I got 5.
There's 5 of this. 1, 2, 3, 4, 5. Gravitational potential energy is mass times gravity times height.
What is GPE?
I don't need to see yours, Emery. You're being silly.
I'm not being silly.
Gravitational potential energy is mass times gravity times height. And if they say it's on Earth, we know that gravity on Earth is what?
Not 180.
9.8.
So can for what I did for the work formula and the GPE formula, it means multiplication, but I just went ahead and just put the X, so it represents multiplication.
If it's written side by side, that's multiplication is understood.
I got the rest wrong.
Yes, go ahead. Hurry. We're right at 10 minutes.
So it's mass times gravitation times height. Wait, don't erase that. I'm almost done.
Wait, so this gonna be all you today?
I'm gonna talk to you some more. We're nearing a time when we should have this test. I'd rather not give it to you on Monday,
I ain't
Please,
but
please.
I'm thinking Tuesday.
I thought we.
What about Wednesday?
I thought we supposed to go
Dog. What about Saturday?
Alright, so y'all work hard.
We're not gonna be here on Saturday, geniuses. That's why I said that. Y'all are.
You know what? I understand that formula now. I didn't understand it at first.
I call
Now
it
I
half.
understand. Did you actually explain it to us?
Now, I understand everything, you know.
Did you actually explain it?
You know. Good job, Miss Fuller. So, Miss Fuller, the only thing that's being squared in kinetic energy is that velocity.
Yeah, and you square that first now. If you don't square that first, you're gonna be off.
So this is basically just 4 formulas on the board, right?
There's 5.
Wait.
GPE.
Oh, I just didn't get MA. My bad.
Wait till. Never mind. Never mind. Wait, no. For the GPE, do you multiply
Yeah, multiply M
Mass
times G times
times
H.
gravity
Mhm.
times height?
Yeah.
Okay.
Have y'all never seen that before where you don't have to put the times if it's adjacent?
I'm never.
I've seen a diet.
Charles. No.
He said B.
That's
Turn into a fraud.
Mark, leave it alone. Just leave it alone. I want you guys to look at number 48 on page 133. 48 on 133. they're making it kinda easy for you in that flow chart or concept map, because they tell you the terms that you'll be using. You don't have to draw the concept map, but you do have to answer A, B, C, D, and E using the following terms: compound machines, efficiency, mechanical advantage, output force, and work output. I want you to do the best you can. You're probably not gonna be perfect on this, but let's see. I want you to start thinking about it. Do you see what we're doing, Nate, where we
Is
are?
this on number 51?
Wait, we on, what?
Oh, wait, hold on.
Wait, what we on?
Y'all, this is page 133. Turn to page 133 to start with.
Whatever.
Are you on page 133, Emery? Nate, everybody,
We're doing number 48.
look at 48. They make it kind of easy. It's not easy, but they're showing you relationships of what we've studied. The topic relationships is one to another, and they give you the missing information. They just don't tell you where it belongs.
You want me to draw it on the board?
No, I don't. We're getting close to the end, and it would be easier just to move forward now. You are to put like 48, A through E. That's what you do to answer this. You'll use one of these words, A, B, C, D, and E. Place them where they belong,
Are we doing
as
something?
they are labeled.
Can I throw something away up there?
Not right now. I want you to just, you can wait. I want you just to work on the problem. Have you already done it? Okay, that's what you need to be doing.
Is it for the grade?
Yes, I'm gonna definitely look at it. It's gonna matter.
Definitely, bro. Can I go to the west room? Bro.
Now remember that mechanical advantage talks about, it compares force, and efficiency compares the amount of work.
Wait, say that again?
No.
If you're talking about what makes up mechanical advantage, you're talking about forces. You're talking about or relating what's involved with efficiency, you're talking about work. So basically, you've got to find where you're gonna put mechanical advantage and efficiency to start with.
Ms. Fuller?
Mm-hmm.
I'm not trying to break the sweat, but what can I find about simple machines and what they combine to make?
Bro, we went over that, dude. It was
Okay, go back to the first lesson. I was really gonna go over this verbally, but I'll take a look at it. Go back to the first lesson when we talked about work, and it talks about machines. It's less than one.
Ooh, I see.
Dude. Bruh. It has the same name in it.
Okay, that's perfect.
Can I have some paper to do it? Cause I throw away mine. Mine. What is it going to be? Markiplier.
Okay, Mark, you did well on that.
Good job, boy.
Game Boy.
Okay, so I've seen Jemiah's, Emery's, Mark's, Nate's.
How did Emery do? He
Okay, well, that's Emery's business. Most everybody's done pretty good so far, but I really need to see, Jake, are you gonna finish yours today? You gonna be able to finish?
I forgot like half the voice.
Okay, so here's the way it works. Charles, are you gonna be able to do this?
Yeah.
Cause we want to get finished in time for everybody to put up their books.
Do you want this back?
I wanna talk to you about this. Okay, y'all, wait. If you put your book up or close the page, you're not gonna be able to follow me. Let's see how you did.
Probably missed one or two.
Okay, that's perfect.
I
Alright,
made 100.
uh-huh.
Ain't no way.
So, look, let me talk to y'all. The simple machines, have two aspects to them that we're describing. They have mechanical advantage or wah-wah, right? And then they have efficiency, so did you pick the right machine? So A is mechanical advantage, and the reason we put it there is because if you look down, it's divided into forces. Okay, mechanical advantage is in forces. So, and if you go over to B, the other aspect of machinery is efficiency, and that's divided into work output and work input. So A is mechanical advantage, B is efficiency, and then C they just throw in there. When you put two simple machines or more simple machines together, you have a compound machine, okay? Now, mechanical advantage has output force and input force, so D is output in force. Efficiency compares work output to work input. Now, as far as compound machines, we're not gonna have time for me to go any further with that. I want you guys to put your books up quietly. Do
Mark.
not get your phones. Where are your phones? Okay. Leave your phones until the bell.
Mark, that was easy. Did you miss that? Did you miss that, bro? Ain't no way. You missed that, dude.
Miss what?
Compound machines.
No, really?
There's no way. There's no way you missed that, dude.
He does though.
I didn't get it right.
So
Am I holding on to it? I'm holding on to it, right? If I still got it? Simple answer, yes or no, Maya.
I mean, yeah.
But you can hold on to it, huh? You can hold on to it. Well, give it back. Okay. There we go.
Charles,
I remember everybody else's. Okay, wait, Charles, please just stay in your seat until
Yeah.
the bell rings.
Louder.
So,
Okay, you don't get a dollar there, Mark.
Hold on, I said you had a perfect score,
After
so,
you.
you got it? Alright.
wait, is they gonna bring my 20 up?
It can't bring it down.
yeah.
Dog.